in a little bit more verbose way, but they don't really change the fundamentals. There's the Redux toolkit and also Redux source. God forbid, please do not use Redux source. I mean, if you're trying to reason about the code, don't use Redux source, because that's a bunch of magic which does everything for you, and you searching for references is hell, and TypeScript is really not friendly with this stuff. So, and the typing can be saved by some other libraries as well, type save actions, for example. You can see that many of those fundamental issues can be solved, but the question is whether we should be still using something which has those fundamental issues. But that's really a question, because many people love Redux, many people hate it. So I don't want to start a flame war. But I guess you get to the point that I don't really like it that much, even though I find it useful in many cases. Well, the indirection is there by design, so it's not going away. It's good fact in one aspect. It's pretty ugly in the other, and the separation as well. I was speaking in negative about Redux, but I guess I could live with all the stuff that I just mentioned. But what really bothers me is that Redux is meant to be used as a single store per the whole application. So any application that you create is always monolithic. You can work around it. You can create multiple stores, but they never communicate together. So it's always hacking. So this is the fundamental issue that I found in Redux. You cannot really make self-sustainable chunks of your code, because everything is bundled in one gigantic store. So no encapsulation, no scoping. It just is a huge pile of data. They say that it's good to have single source of truth, and that Redux brings this single source of truth. There are two interpretations. I mean, there are two different things: single source of truth and all truth in a single source. I tend to think that Redux brings the second point. I mean, it collects all the truth into a single place where you can take it from. But having a single source of truth doesn't necessarily mean that it needs to be in a single place. It means that every truth has its only place where it's stored. And sometimes Redux forces you to do the other way. For a good example is routing. If you have router 5 and you connect it to Redux, you're actually copying the source of truth, because you have URL as one source of truth, and then Redux as another source of truth, which somehow try to be in sync, but why? So these are the issues that I have with Redux. So what are the alternatives? I guess there were many of trials and failures. Many of them could be even better than Redux, but they didn't have the traction to actually make it into life. So, but recently they changed with the introduction of hooks and the context API, which was already there, but nobody knew about it. And now everybody is shouting that they can replace Redux with hooks and context API. So what is it about? It's just a good old lifting of the state, right? So you have several components, and you don't manage the state in those components, but you lift the state to the parent component, so you can share it. Without context API, you would do it through props. So you would have a chain of components which you pass the props to the components down there. With context API, you can skip those levels. You can just inject it directly to any kind of component below your parent one. So you do it with hooks. You do it quite easily. You have use state in the parent component, then you create the context in that parent component, and then you consume that context through use context in the child components. What does it bring? It means that there is no separation of logic from component whatsoever. I don't think either of ways, like having everything outside of components and having everything inside of components, these are two extremes, and I think everything, like in anything in life, extremes are not good. So there should be some kind of a balance. But currently, context API and hooks don't give you really much choice. you need to bundle everything inside your component. Yes, you can use reducer, extract the function somewhere, but then we are kind of re-implementing Redux with all these actions. So no, thank you. It works kind of fine for simple shapes because you can have simple state in the use state and you can just replace it. But it becomes very, very complex and inefficient for complex shapes. If you have an object and you want to mutate several properties of that, you have several functions created inside your parent component, and then you pass everything through the context. So the component is huge. And further, and more importantly, if you change one property of this state of yours, then all the components listening to the context will be notified and will re-render, which is kind of waste of CPU because the data that they are consuming didn't really change. There are no selectors. That's the message. And transformation of data always happen directly in the components, right? You consume the state, you consume the context, and you transform it using use memo or whatever to speed it up. But still, it's being done directly in the components, and it's also being done during the rendering. So if you have some expensive computations, it's not really ideal. This, of course, applies also to Redux, because if you're using selectors from Redux, they are also called whenever the component renders. So there is one obscure thing with use context, well, context API itself. I haven't seen anybody use it because it's kind of cryptic. There's something which is called observed bits. It's a number that you can generate while you're making a change in the context, and you can say that you want to consume the context only if this number appears, and it's kind of, I mean, it's a bitwise operation. So it's very weird that creators of React, which is kind of clear and readable, came up with this solution, which nobody happens to use. So this is just a simple showcase how the plain context API solution works. So we have this form here with first name and surname field input fields, and then you have a person state lifted to the parent form, and it's dispatched through the context to the inputs. So what happens now when I try to change surname? I'm getting an event or call to a callback inside the form parent form component, and that prepares a new person with the updated surname. It replaces the original person, and then it travels through the context to those components. So both those components are triggered, re-rendered, and wasting a lot of CPU efforts. So we kind of set up some goals for our new proprietary implementation. So what we learned from Redux is we need to be simple and have a direct API where you don't need to think and look up multiple files in order to find where this particular action is made, it's being performed. Should be modular in the sense that I don't want the state to be in a one gigantic object. It should be split into some chunks. Those chunks should be able to cooperate together. And definitely it should be fully typed, because TypeScript is now getting more and more traction. I guess it's very useful for bigger projects. So TypeScript rules. It should have low verbosity, because that's what bothers me as well about Redux, that you need to write a lot of stuff. So what we took from the context API approach is that we don't want to render components when there is no need for that, and also that we would like to have at least a partial separation of logic from the components. And then the common issue that transformation should probably happen somewhere else than during the rendering. So the plan was to use context API to create some kind of a tunnel and to push new changes in the state through that tunnel, so that only some interested components can connect to the tunnel and pick the information, and to actually see, actually tell which components should receive the updates. We will use some filtering and transformation of the state as it flows through the tunnel. So the idea is following. Again, we have the same form. This green space is the tunnel. So whenever we have a surname update, goes to the form as well, and then you have the new person is being computed. It's still the same. It replaces the previous one, and then it's dispatched through the tunnel. But it reaches some points where we are actually making the transformation and filtering. So only the surname will be notified this time, and first name will remain untouched, because it doesn't really care about changes in surname. So when I already mentioned that it's a reactive tunnel, so we are pushing things through something, through some streams. So the obvious choice probably was RxJS, because to my knowledge is the most popular library for streams. And yeah, it's well established and it has a lot of operators that you can use. Probably in your lifetime you won't use all of them. It allows easy transformation and filtering, and it also offers you time-based transformations, which is something that you cannot do with Redux at all, because Redux is strictly synchronous. So what are the basic building blocks of our framework, in quotes? It's a replacement for use state, use observable state. The difference is that it doesn't really generate new objects each time you change it. It generates only once. Okay, it's a behavior subject with some kind of a default state, like you would do with regular use state, and it provides a callback in the exact form as use state, which you can use to update that state. But by updating the state, it doesn't mean that it changes the behavior subject. It just dispatches a new snapshot, new state through that subject. For those of you who don't know RxJS, behavior subject is both an observable and a subscriber. So you can well, it's kind of hard to explain in a few seconds, but subject is something through which you can send something and to dispatch it to multiple subscribers, and the behavior subject is especially in that case that it keeps the last state that you pushed through it. So you can query it. You can say get state, and it will give you the latest state that went through the behavior subject, which is important if you want to do partial modifications, because you need the previous state in order to merge it. So, and the behavior subject is then passed down through the context or props, or however you prefer. It's just an object, so you can pass it anywhere. It doesn't change through the entire life cycle of the component. It's still the same instance, so you don't need to care about. Well, if you pass it through the context, you can be sure that the consuming component will not re-render just because you emit a new value. And the component needs to subscribe. That's where we use it, right? We use it on the parent component, and then we consume this, or we are subscribed to this stream or the tunnel through use snapshot. Use snapshot takes an observable and returns a snapshot of that observable. What is a snapshot? Snapshot is always the latest value that went through the observable. So if you are instantiating a new component, it looks what was the latest emission from that observable, if it has such a latest emission, and then returns the value, and you can use that in the component. If when then the observable emits a new value, the component gets updated, and you will return gets re-rendered, and you will retrieve the new version. That means the component will really be re-rendered only in the moment when new value is emitted, and the component is interested in that value. So that's what we use here in the subscribing components. And then we spoke about transformations. So transformations are being done through regular RxJS way. So we have this pipe method on any observable which we can use and pass in some operators, and the operators will make sure that the stream gets transformed. And of course, it's useful and probably necessary to memorize those pipelines so that you have a stable instance of the resulting observable. So that's what we use here as well. So this was a lot of theory. Maybe it will be clearer for you if you see it in action. And so this is actually the form. Reactive person, I call it controller because it controls the state. So you see, instead of using use state, I'm just using use observable state, but then it looks the same. You can notice that the person has a $. $suffix is kind of a convention in the reactive world in observables that you don't always write observable, right? Because you would write person observable, so you write person $. It's something which is pretty established. So we're following the convention as well. So we're creating an observable with the default state and getting back the observable and the callback. Then we prepare a value, context value, that will be passing down the context. So we memorize it in order to avoid re-rendering the listening components. Apart from the person itself, we are creating some handy setters. So set first name is going to update the first name of the person. You can see that we are using the set person inside. And then we're going to dispatch that context value through the context API. Simple. And how does the component that consumes this looks like? It's like this. You first get the context, right? So currently we are here we are destructuring the context value. So we have this person observable and the set first name callback. Then we do the transformation. So we pipe the person observable. We provide the map operator, which is like map in arrays. So it's just it's a projection, right? So you take the person and you project it to you map it to its first name. So the resulting observable will be emitting first names instead of the whole person. And then you use this use snapshot thingy. So you provide the observable, and the result is the first name snapshot. So you get always the latest first name that was ever transmitted through the person observable. The use snapshot uses use state under the hood, and thanks to that, it doesn't re-render if the value that is emitted from the observable is still the same. So if the first name doesn't change, the component is not re-rendered. Therefore, it stays like that. So that's the basic idea. Well, yeah, one more thing. This may look a little bit complex. You need to map first and then use memo to memorize the pipeline. So we came up with a handy shortcut. So there's this use partial snapshot which combines these two operations together, because that's what you usually do. You usually use a selector to select part of the state, and then you want to snapshot it. So we connected it together. So it's only one hook. Sorry. So did we achieve our goals? I guess it's kind of simple and direct API. It's very modular, maybe too much, because you can build your state anywhere and you can consume it anywhere. It's definitely fully typed because RxJS is actually written in TypeScript, so you get the typings for free, always fresh ones. The verbosity is kind of low, at least to my standard. And yeah, we don't render the components when we don't need them, which was one of the most important things for me, because I tend to do a lot of premature optimizations. Transformations happen outside of rendering currently, because they happen in the moment where you are pushing through the stream, not in the moment when you are reading the values. And did we have any kind of separation of logic? I don't think so, right? We bundle everything inside the component, so that's not yet really covered. So the answer for that is store. Store is just a concept I took the name from Redux. It's just like a container for your application, for your logic, for your state logic, and for your selectors or transformations. Every store extends behavior subject. That's what I explained what it is already, and adds an update method, which is kind of just a shortcut, because each behavior subject has a next method through which you emit the whole state. But the update takes a partial state and merges it with the current one, so it behaves similarly to set state, for example. So as I said, the store should contain all the mutation logic, and also should define the transformations so that you can reuse them. You don't need to implement them at all the places that you use them. So this is an very simple example of a store. It's meant to store a single person. So the first two properties that we have here are transformations, or you can say selectors in this case, because they just don't do anything. Then they pipe the observable itself, the store itself, because store is observable, right? So you can pipe it. Then you map the person to the first name or to surname, and you create a resulting observable. And you can subscribe to that observable from many places, and it will give you the same values. Then we have those callbacks for the setters that you already saw in the previous example, but here as well we have it separated from the components. And we are using this update method here to facilitate the updates. You can notice that we are using here, we don't use methods here, we use class fields. That's just for convenience, that we can then destructure the store easily without losing the context of the store itself. So you know, if you would be method and you destructure it, then you would lose this context, so you would be screwed. And so this is how you use such a store. You remember how complicated the controller was earlier, so now it's way simpler. You just memorize the store because you want only one instance of it. So you assign it a default state, and then you pass the store down to the context. And the consuming component didn't really change much, because we're just grabbing the selector. So that's something that we dropped, right? There was this complicated piping and snapshotting, or the partial snapshot. So now you directly get the selector, so you can snapshot it easily, and you can render the value. Didn't really mention earlier, but here you can see that there's a special callback on value change, which is triggered whenever you change the input. But I guess you got the point. So it's calling the callback from the store, and therefore emitting a new value, and the value comes back through this observable, and then we render it. So it's just the way the life cycle. So I guess we've covered all the goals that we set up earlier. We now have even some kind of separation of logic. So what's more? As I said, I tend to do a lot of premature optimizations, and I hate unnecessary renders. So this the implementation that we did is kind of helping me with that a lot. So the use snapshot, as I said, ignores emissions of the same value using a strict comparison. Use partial snapshot goes a little bit further because it accepts a custom equality function, and it uses shallow equality by default. So whenever you select part of your state and that part happens to be an object, you can be sure that it won't retrigger the rendering unless the values or the shallow values of that object change, or it can be an array as well. If you want more custom memoization, then you can use distinct until change operator, which is part of RxJS. As the name says, it will emit only distinct values until it changes. And you can even provide your own equality function, so you can customize the behavior to your needs. If you have expensive transformations, you need to understand that if you do the piping creates an observable, but the observable is just the pipeline actually gets triggered each time you subscribe to that observable, and each time the source observable emits, all the pipelines are being executed. So for each subscription, you will compute all the things that you are doing here. So in this case, this is a selector in the store, right? So if I would subscribe to it from two components, then this get initials would be called twice if it wouldn't be optimized. And the optimization here lies in this share replay operator from RxJS, which makes sure that it so-called multicasts the changes. So if the initials, well, if this emits a new value, then the map will be called only once, and it will be distributed to all the subscribers. So that's what I found nice, and I put it everywhere in our code. And then, oh fuck, I found out that there is a brutal issue with this share replay, and that the brutal issue is that it doesn't unsubscribe from the source when all the descendant subscribers are gone. So it creates memory leaks. So I started looking into in GitHub and found a lot of issues about this. Nobody seemed to be eager to solve it, but they all recommend using publish replay and ref count, which is basically some more low-level thing. The publish replay will make sure that it's multicast, and the ref count will make sure that it subscribes to the source only when there are some subscribers, and it will unsubscribe when there are no subscribers. So I tried, and publish replay has also a very kinky property, and that is that it reuses the underlying subject which it creates. So yeah, it properly disconnects, it properly unsubscribes from the source, but when you subscribe again, it first emits all the values that it remembers, and then it emits the values from the real source. So it's kind of weird. I don't know why this behaves that way, but there is a solution, so you need to be a little bit more verbose. This is kind of a detour. I just wanted to let you know what I faced in the recent week. Okay, as I mentioned, the benefit of RxJS is that it also can transform in time. So you have some operators which work with time, like buffer, filter. Filter doesn't really work with time. I don't know why I wrote it there. Debounce or throttle. So it's just about choosing the right one. And we have an example here of an autosave functionality. So let's say we have this person observable. It's the store actually. And actually, this is not a store. That doesn't matter. It's a person observable which emits the whole person whenever anything changes on the person, right? So if you change the surname, if you type a letter in the first name, it gets updated, and the person observable emits a new value. So we definitely don't want to save on each change, right? Because you would be saving on each key press. So we need a little bit of debouncing, and it's very easy to debounce with RxJS. So we create a pipeline. We skip the first emission because the first emission is probably going to be the loading. So if you have a form, and you load the value inside the form, you don't want it to be saved, right? So you skip it, and then the rest will be debounced by a certain amount of milliseconds. So the debounce person observable will emit only when there was a change that happened, and for some amount of time there was another change. So that's debouncing. And then we use subscription, which is another hook from our framework, and we subscribe to that observable, and whenever it emits, we just save the person. That can be, I mean, I don't want to complicate it with asynchronous actions here because it would make the example pretty hard. So you can imagine that it's saving somewhere the person. But that's of course just an example, right? You can do a lot of things with time operators of RxJS. Yeah, when we are speaking about time, some observables are not synchronous. They tend to wait and then emit. So during this waiting period, you should know that it's waiting, and you should know where it's emitting. There's also a complete life cycle of the observable, so it waits, then it emits, and then it completes, or it fails. So the uSnapshot returns actually 3 values, not only one. The first one is actually the actual last emitted value. The second one is the state of that observable, and the third one is an eventual error. I took an inspiration in Apollo client because that handles it nice. Yeah, so observables are kind of superset of promises. So you can convert any kind of promise into an observable and treat it in the same way. So since we already have a mechanism to snapshot the observables, we can turn any promise into an observable and treat it in the same way. So that's also a good feature. Yeah. So as I mentioned earlier, that I want independent stores, right? Independent places where we keep the state, and that I want them to be able to cooperate together. So this cooperation is done through combine latest, which is again part of RxJS. It's nothing I would be inventing. Yeah, you just combine multiple sources, and then whenever one of these sources emits a value, the resulting observable emits a combination of these values. So you can map it then to whatever you want. This example here says that the save button should be enabled only in case if you have enough authorization for that, and if it's not if the form is not empty, right? So this is how you can combine two different stores together, or two different. It doesn't need to be store, right? It's just a simple observable. Yeah, I kind of like this explicit dependency because in Redux you have very implicit dependency. It's very hard to see which part of state is dependent on which other part of state, which is merged together in some situations. You don't know that because it's a huge object, and these things are scattered among a lot of selectors and a lot of files. So it's very hard. You come to a component, you see that it's using some data, then you need to go to the selector. You see, now you're already spending a lot of time understanding how that works, and here you have it immediately visible. Yeah, so that's mostly everything from the main concept. And there is one more which I really like because I hate how dialogues work in React. Because of the nature of React, you don't have anything like, okay, now show dialog and give me a promise of the result. So which was the way how I always did it with JavaScript before React. So with dialogues and Redux, it's even worse. You need an action to show the dialog, an action to hide the dialog, an action to actually perform that action that you want to perform, and then you need a selector to see whether the dialog should be open, and also to get the data that the dialog should display, right? And then what if the data changes during the period where the dialog is open? Your dialog is actually obsolete, and you don't know if the action is still applicable. So the answer from us is intent, something that combines data and the performable options into a single object, actually into a single stream, because it's kind of a life. It's you subscribe to the store, and the store makes sure that your dialog is always up to date. It's kind of abstract what I just said, but it's not hard to understand it when you see the code. So imagine the situation that you face everywhere in every application. You have a list of something, some records, and you want a delete action, right? So if you want to delete something, you should probably ask whether you really want to delete that. So you go through this dialog hell. So the intent is meant to be used in the following way. You have a function that takes some parameters, like in this case, it's an ID of the record that we want to delete, and it returns an observable. And it returns an observable of intent. And intent is a special kind of object which contains some data. Like in this case, it contains the record to be deleted, which is something we found from the current state. So you see it's piped, so it will always refresh whenever the state changes. And then it contains the action to be performed. So in this case, it's called perform. It can be called any other way, which actually deletes that record, right? And the deleting can happen only if we actually found that record. So if you don't have it, it makes no sense to have a callback that deletes it. So we're returning undefined in this case. And the usage is also kind of simple. You have a delete button, which has the ID of the record that you want to delete, of course. Then we fetch the store, yeah, that's obvious. And we have a state where we keep the intent. Not the intent itself, but the observable of the intent, which is by default null, because we don't want the dialog to be open, of course, and we don't have the intent. So what we do is we render the button, right? And if the button is clicked, we create the intent, actually the observable of the intent, using the store method, and then we set it to the internal state. Once we set it to the internal state, it will render the dialog itself and pass the intent observable inside of the dialog. I mean, this is just an extraction. It could be directly inside here, but I kind of prefer if the dialog is a separate component. And of course, if the dialog is closed, then we want to reset this intent, so we hide the dialog actually. So the delete dialog looks something like that. You just make a snapshot of that intent, and you just work with it. So if the record is not there, you display a message that it's not there. If it's there, then you display a confirmation dialog where you're saying, do you really want to delete blah, blah? And a button to confirm that. The confirmation is, again, quite easy. You just close the dialog and you say intent.perform, because I want to perform that action that intent prepared for me. Of course, we should do some checks here whether the perform is available. But for the simplicity of the example, and because I forgot, of course, I didn't do it. So that's it about the general introduction to our framework. And now it's more about the experience that we had with it in the Configurator SDK. So in Configurator SDK, we have 3 stores, 2.5, let's say, because the navigation part is not really a store. It pretends to be a store, but it's just a proxy or wrapper, and the wrapper can be backed up by an actual store or by something else. So the navigation here, it contains all the logic, like if I select a certain part or a certain section, then I should get the camera focused on that section, and I should also clear all the freehand camera. So if I do something with my mouse and then I select a section, it should be navigated directly to that section. The camera should focus the particular part of the vehicle. So this is all in here, and then it just uses some storage to store this information. So you can either store it in memory, or you can currently, or you can store it in root, in URL. So we are using router5, some kind of a wrapper that provides 2 methods, actually, subscribe and update. So it behaves like a store. And so whenever I change something in here, it gets propagated to the URL, and the URL displays it. It would work the same way as well for the opposite direction. The benefit is, of course, having it in the URL is very beneficial because you can just copy paste the URL to a different browser, or to send it via a link, via an email or whatever, and you get directed to your configuration. The product configuration is a store where we keep all the selected options and stuff. So that's kind of an easy shape. The flags as well, it's just a few Boolean flags where we keep information whether the animation is running, the camera is moving and stuff. So we can add the UI based on that. What's very important for our configurator are the intents. We're currently using only 2 of them, but they are very important because they are handling the adding and removing of all the options that you have inside the configurator, and they are running some kind of complex logic of generating patches. So if you select an option and the option depends on some other option, then you need to be presented with a dialog where you can confirm that you want both those options. If you select an option which is incompatible with some other option, you need to be again presented with the dialog confirming that you want to remove that incompatible option, and so etc. So it's kind of complex. We're currently using I don't know, I counted by full text search. This might be not accurate, but we have 14 usages of partial snapshot and 4 usages of use snapshot, which really makes me sure that it was a good idea to introduce this shortcut, because it's pretty convenient and people tend to use it, evidently. So what are the pros that these are my personal opinions, but I guess the team shares them basically. So it's easily pluggable, the whole store thingy and the RxJS. Not only that, it can be plugged into the containing app very easily, because we can wrap everything inside a single component and have everything scoped. You can even have multiple configurators on the same page if you want. You can decide whether it's going to be driven by URL or whether it's going to be driven by memory, because you already have some routing and you don't want to mess it up. So that's very, very easy to set up. It's easy to trace the dependency. That's what I already mentioned. So if you find a component which is doing something, you can immediately navigate yourself to the store and see what it actually does. Great typing support. I already mentioned it as well. Clear separation of concerns. Yeah, you saw that product configuration store. You saw that flag store. You saw that navigation store. It's separated, but it communicates together. We didn't find any major issue. There was several little ones which we usually managed to fix. I recently discovered this thing with the shared replay, that it's actually creating memory leaks, and it's not only memory leak, because it's also we were using it with the intent. So anytime the intent was created, we created a new observable, new pipeline, and anytime the new one was created or a change happened, all the pipelines were run. So if I clicked a lot in the configurator, then those patches, which is kind of expensive operation, were generated a lot of times. But I didn't see any kind of slowdown in the UI, even though I clicked like a madman. So I guess the overall performance of the solution is quite sufficient. And the team seems to be happy. They like that they don't need to work with Redux, that it's simpler. And for our use case, I guess it's way sufficient. What I really find nice is that this is related to the separation of concerns. It's just you have a single store for a single thing, so you can easily test it, right? You can write a unit test around the single store. If there are dependencies between the stores, it's always clearly specified. I mean, if one store depends on another one, it needs to take the other one in a constructor, for example, then you know what you should mock. So it's pretty easy to test it with unit tests. The drawbacks are it's not a well-known library. Yeah, that's it. That's the most important thing, I guess. It doesn't have documentation. It doesn't have Stack Overflow support. That's of course, But it's, I guess, with every new feature new library that comes. Yeah, some ideas are not yet entirely finalized. We were doing it on the fly while rushing with the Configurator SDK. So there's still some space for thinking. And yeah, we're lacking the debugging tools that Redux has. That's something we don't have, but everything is observable. So theoretically, for debugging, you can connect all your stores together and log everything into console to find out your issues. Of course, it's not as convenient as using DevTools and Redux. There's one thing I wanted to pinpoint on what we on Configurator SDK and why I really liked where I really liked RxJS, and that's this view state patch. It's the 3D model that we have changes, right? If you select an option, then the 3D model changes because it replaces the wheels, it changes the color and stuff. This 3D model is unfortunately not declarative, right? It's just a huge bunch of objects which you can manipulate with imperative commands. So we needed a way how to transform the state or the change of the state into a set of instructions, and that's a perfect use case for the scan operator of RxJS, which works similarly to reduce, but in time. So you have the previous value, you can compare, you can generate some instructions. So that's something which was really neat. Okay, that's it. So that's what's currently done. What is to do right now is, at least that's what we want. We want to publish it as an NPM package. Actually, 2 of them, because there are some low-level hooks which are useful also outside of the RxJS scope. So that's what we would like to have separate. And then based on top of it, we would like to have this RxJS NPM package as well. At least me, I would like to open source it, but depends on how we will handle it. For that to happen, we need to sanitize the naming, because the naming is crazy. I mean, there are pretty confusing things, and even for me. So yeah, that's always the worst thing, right? The hardest thing. There are some helpers and shortcuts which are not really useful, and they just add complexity. So we need to remove them. You need to finalize those ideas that I mentioned. And the code definitely should be covered with unit test, which is kind of a fact already, because we have a lot of tests. Most of the hooks are covered with unit tests. By the way, I'm using the React hook texting library, which is pretty neat, and I will hopefully have a Brambeck about it soon. And of course, we need documentations and samples here. What I would personally want is to have somebody here interested. If there is a volunteer that wants to give it a try, either to as a user or even as a contributor, I would be very happy, and I would be happy to give him a proper introduction to the code. That was the immediate plan, and now the further maybe future plans is to add React Suspense support, because as I told you, the observables, some of them are not synchronous, so you need to wait until it starts emitting, and that's a perfect use case for React Suspense. So you can suspend the components until the observable starts emitting. And then something which I really, really would like to do, and I'm thinking about it since the moment I saw Redux, and that's hierarchical stores. Imagine that you have a list of records and in the store, and then you always need to, when you manipulate them with them, you need to say, okay, now change record ID and the value. So I would like to have something like, give me a projection of a record number 5 or ID 5, and then you would have an object like a pseudo store where you could have some sub-selectors, and you could also have setters, like if you like with the person stuff. So if you would have persons and person, and you would write to the person, it would write directly down to the list of persons, and it would immediately project back to your observable, which is kind of doable, I think. So I'm going to tackle it hopefully when I have time. It doesn't really make much sense for our project because we have really simple shape. But maybe when it starts becoming a little bit more complicated, I will have time to tackle that. So I know it was quick because it was a lot of information. I wanted to cover well, most of the aspects at least. So sorry for rushing. But if you are interested, let me know. I will gladly give you a more deeper overview. And for you who want to look at the code, the code is inside the Configurator SDK repository. This is a direct link to the folder where most of these things are defined. But you can also scan the whole repo if you want. Yeah, that's all from me. If there are any questions, I'm happy to answer them.